projects. In this video, we are going to explain about the project titled BSSPD, a blockchain-based security sharing scheme for personal data with fine-grained access control. Introduction. The project primarily aims to enhance security and privacy in data sharing. It proposes a scheme called BSSPD, which leverages three critical technologies: blockchain, CPABE, and IPFS. By utilizing these technologies, the scheme ensures secure and user-centric data sharing with fine-grained access control. Blockchain provides data verification and fault tolerance. CPABE offers encryption and decryption capabilities, and IPFS enables decentralized data storage. Traditional data sharing approaches were centralized, relying on cloud servers, which posed risk to security. Even with the introduction of encryption, dependence on third-party providers for security was a limitation, reducing control over data. BSSPD addresses these concerns by decentralizing storage and utilizing encryption in a more controlled and secure manner. Blockchain is a fundamental technology in BSSPD, enabling decentralized data storage. It ensures data verification and fault tolerance by associating a unique hash code with each data block. This hash code allows tamper detection, reducing the reliance on third-party verification and enhancing data security. Ethereum, a popular blockchain platform, is utilized to implement and deploy smart contracts for BSSPD. Smart contracts are self-executing contracts with terms directly written into code. In this project, Ethereum is used to deploy smart contracts that define the rules and processes for data sharing, access control, and management, contributing to the security and functionality of the BSSPD scheme. Objective: the project significantly improves data security and privacy by leveraging blockchain and encryption. Blockchain ensures data immutability and integrity, making it tamper-proof. Encryption adds an additional layer of security, protecting data from risk associated with centralized cloud storage. BSSPD provides data owners with precise control over who can access the shared data. This control is facilitated through CPABE and blockchain. CPABE enables fine-grained access control based on attributes, and blockchain validates and enforces these access policies, allowing only authorized users to decrypt and access the shared data. By utilizing blockchain, the project reduces dependency on third-party verifiers for data security. Blockchain's inherent verification capabilities enhance trust and security by providing a decentralized and trustworthy way to validate data, mitigating risk associated with relying on external parties for verification. Integration of IPFS enables decentralized data storage, improving fault tolerance and reliability. Data is distributed across multiple nodes, reducing the risk of a single point of failure. This decentralized approach enhances data availability and resilience. The project emphasizes a user-centric approach to data governance. Data owners maintain ownership and control over their shared data. They can finally manage and revoke access at an attribute level, preserving privacy and control, empowering users with more authority over their own data. Requirements. The requirements of the project are hardware requirements, in which we have processor of Wi-Fi and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements, in which we have Node.js, Python 3.7.0 version, and Visual Studio Community version. Methodology. To implement this project, we have designed the following modules. The first module is New User Sign Up. This module facilitates new users to sign up and create an account within the BSSPD system. Users provide necessary information during sign up, which is then securely stored on the blockchain. This module is a fundamental step for users to become a part of the secure data sharing platform. User login. The user login module enables users who have already signed up to log into the BSSPD platform. Users authenticate their identity by providing their credentials, gaining access to the system and their associated functionalities. Secure login ensures that only authorized users can access the system. Share secured data. In this module, data owners can securely share their data with specific users. The data owner can upload messages, images, or other data and define access policies based on user attributes. The module encrypts the data and the decryption keys based on these policies using CPABE and securely stores them on IPFS. This ensures that only authorized users can decrypt and access the shared data. View shared messages. The View shared messages module allows users to view the data shared with them. If a user has been granted access to specific data, they can view and decrypt the shared messages or content. This module ensures that data is accessed only by users with the necessary permissions, maintaining data privacy and security. Storage overhead graph. The storage overhead graph module is focused on providing insights into the encryption and decryption time overhead. It presents graphical representations illustrating the time taken for encryption and decryption processes. This information is essential for understanding system performance and making informed decisions regarding data sharing and access. Blockchain integration. Blockchain integration in BSSPD ensures decentralized data storage by distributing data across multiple nodes, enhancing fault tolerance and high availability. This approach reduces the risk of a single point of failure, providing a resilient storage mechanism for shared personal data. Each data block in BSSPD is associated with a unique hash code verified by the blockchain before storage. This verification process ensures data integrity and authenticity. Any attempt to tamper with the data would alter the hash code, causing verification failure and effectively making the data tamper-proof. BSSPD leverages blockchain to control and manage data access effectively. Blockchain distributes key and access policies to authorized users based on predefined criteria. Only those users meeting the specified criteria can decrypt and access the shared data, providing fine-grained access control and ensuring precise management of data access. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is blockchain security folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is blockchain security app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. This blockchain security app folder also contains a templates folder. Inside the template folder, we will find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. This folder also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is Hello ETH folder. Inside this folder, I have Node modules folder. This folder consists of dependencies or modules needed for the project. Open .bin folder. The .bin folder often contains executable scripts related to the project's dependencies. So we have a run blockchain.bat file. Double click on it to start the blockchain. This script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at this local host, which is this, and port, which is this. This address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. This is the unique contract address. This address represents the location of the deployed smart contract on the blockchain. This is the gas used to execute the Solidity file and compile smart contracts. This is the amount of gas consumed. Now minimize this. Go to the main directory. This is blockchain secure sharing Solidity file. This file consists of Solidity code. It handles data structures, functions and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations and more. This is start IPFS file. After deployment, double-click on it to start the IPFS server to store images of the application. So here we can see that IPFS server is ready and it will run in the background. Now minimize this. This is run server. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double-click on it to start the Django application. So the Django framework will host the application locally at the default address localhost, which is this, and port, which is this. Now copy this local link. I am copying the link and paste this copied link into any web browser. I usually prefer Google Chrome. And type index.html at the end and hit enter. This is the homepage of the project displayed in the browser. This is the front end built using Django framework. Now click on new user, sign up here to register the new user. So here we need to enter all these details to register. So I'm entering the username, password, contact number, gender, which is female, email ID, and the address. After entering all these details, click on submit. So here we can see sign up process completed and record saved in blockchain. So in this way we can register n number of users. So again click on new user, sign up here to register one more user. Enter the username and the password and the contact number. Select the gender, which is male here, email ID and the address. And after entering all these details, click on submit. So we can see sign up process completed and record saved in blockchain. So we have registered 2 users now. Now again click on new user, sign up here link to register one more user. Enter all these details. So I'm entering the details, username, password, contact number, gender is female, email ID, and the address. Now click on submit. So the sign up process completed and record saved in blockchain. So we have registered 3 users with 3 different username and password. Now click on user login here. To log in, enter the username and the password and click on login. So we have logged in as True Projects 1. Now click on share secured data to share the data. So here we need to enter the message. And we need to upload a photo. So choose file. And open. So here I have entered the message and chosen a file. Now here we need to choose shared users. So I want to share this image with True Projects 2 as well as True Projects 3. So I have selected both the users. Now click on submit. So here we can see shared data saved in blockchain with below hash code and image file saved in IPFS. Now click on view shared messages to view the messages which have been shared. So here we can see we got the details of data owner, shared message and IPFS image address and the shared image and shared data users. So this is the owner, that is True Projects 1, and the message which is being shared is office photos, and this is the shared image, and this message is being shared to both the users, which is True Projects 2 and 3. Now click on storage overhead graph to view encryption and decryption time overhead. So here we got the graph for uploading, encryption and decryption overhead graph. The x-axis represents encryption and decryption and y-axis represents time overhead. Now close this graph and click on logout. Now again click on user login here to log in as the second user. So I'm entering the username and the password and click on login. So here we have logged in as the second user, which is True Projects 2. Now click on view shared messages to view the messages which have been shared. So here we can see this is the data owner and this is the shared message and this is the IPFS address and this is the shared image, and this message and the image are shared to both the users. Now click on logout. So in this way we can add number of users and then we can share the data to all the users, or we can share to only 2 to 3 users and then we can view the message. Conclusion: the project effectively demonstrates the formidable security impact achieved by integrating blockchain, CPABE, ciphertext policy attribute based encryption and IPFS. By combining these technologies, the project achieves decentralized data storage, robust encryption and precise access control. This amalgamation significantly strengthens data security and privacy. BSSPD places a strong emphasis on user-centric data governance, ensuring that data owners have significant control and ownership over their shared data. Through well-defined access policies and attribute-based access, data owners can assert control, fostering trust and confidence in managing their personal information. The integration of blockchain and IPFS is pivotal in enhancing the efficiency and reliability of data sharing. Decentralized storage through IPFS improves fault tolerance by reducing dependency on a single point of failure. Blockchain ensures data tamper-proofing and efficient access control, bolstering the overall reliability and security of the data sharing mechanism.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit Through Project's YouTube channel and subscribe.